Thank you, sir. Now, I would like Mr. Ramchand Singh Chauhan to kindly present the bouquet to Director R&D Dr. Vivek M. Vasikar. Now, I would request Dr. Pranay Vav to kindly present the bouquet to Dr. Madhukar M. Rao.
Let them guess out. Let the guess out.
Sir.
Guess out. Let the guess out.
Sir.
Put your hands together for this.
Roll your director name.
Put your hands together for this. Now, I would request Dr. Ashutosh Tiwari to kindly present the bouquet to our Director Sir, Dr. Reddy. Now, I would request Dr. Ashutosh Tiwari to kindly present the bouquet to our Director Sir, Dr. Reddy. Thank you, sir. Now, I would request Dr. Ashutosh Tiwari to kindly present the bouquet to our Director Sir, Dr. Reddy. Thank you, sir. Now, I would request Dr. Ashutosh. Now, I would like to call Dr. Ashutosh Tiwari to kindly present the bouquet to Dr. Rao. Thank you, sir. We would request our Honorable Director, Sir, R&D, Dr. Vivek M. Vasikar, to kindly come to the dais and welcome our chief guest and proceed with today's event and make it a success.
Respected chief guest.
Respected guests and guests of honor, respected speakers, respected directors, my dear colleagues and students, it gives me immense pleasure to welcome the occasion of this one-day seminar on research and development trends in technology and sustainable innovation. This seminar is second in the series of compact one-day seminars and brings interest, excitement and energy to academia to discuss relevant issues in research and development. It primarily deals with research and development trends and presents how technology and sustainable innovation are current industry's drivers. The speakers are heads of industries working in the fields of technology development, new products, and sustainable innovation. The seminar discusses energy efficient technologies and, like its predecessor, also opens up channels for mentoring and consultancy. By providing an environment of effective learning and innovation, this seminar is expected to build a stronger research impetus for collaboration and partnerships in the domain of research and development, for student interaction, long-term collaborations, product design, development and manufacturing, consultancy, entrepreneurship, and establishing industry-rich learning. With this note, I would like to welcome our chief guest, Mr. Harish Sippy, guest of honor, keynote speaker Dr. K. Subramanian, and I also welcome all the participants here. I welcome especially our chief guest and guest of honor who are experts and eminent personalities for enlightening minds and spirits. With this note, I thank you all and let the chief guest deliver lecture. Thank you.
Thank you, sir. Here comes that moment you all are waiting for. Our first speaker of the seminar is Mr. Harish K. Sippy. He is Chairman and Managing Director of TEMA India Limited, a company specialized in manufacture of heat exchangers since 1975. He is renowned industrialist in the engineering space of engine oil and gas industry. Sir is a visionary leader who places great emphasis on creativity and innovation. Under his leadership, TEMA acquired an Indian patent for the fitting the shrink ring on the threaded portion of the screw plug enclosure. His mantra for success is turning small opportunities into great success. Sir is passionate about coaching and mentoring for creating a talent pipeline in the organization. He is our chief guest of the seminar, so welcome him with a huge round of applause.
Thank you. Thank you, gentlemen. I'm so honored to be here. Can I be heard? Yes. Can I be heard? Thank you very much. I'm truly honored to be here. And thank you, my friends. I consider students as my friends. That's the only way I can survive. Because all the knowledge is hidden within you people, the purity of mind. अभी हिंदी में भी बात कर सकता हूँ मैं? अरे वाह वाह वाह, क्या बात! मेरी हिंदी काफी वीक है, इसके लिए कभी कभी मैं इंग्लिश में जाऊंगा। हम लोग की हालत क्या है? हम लोग तो धोबी के क्या बोलते हैं, सॉरी, है ना? अब करे क्या कर सकते हैं? ना इंग्लिश जानते हैं ना हिंदी जानते हैं। चलो कोई बात नहीं। हाँ, तो इनोवेशन है क्या चीज? समथिंग न्यू, राइट? कहां बैठने को जाओगे? क्या न्यू करना है, क्या नहीं करना है? मतलब बोला जाएगा कि हाँ ये इसको न्यू करना है, तो वैसे तो होगा नहीं। हम जो चाहेंगे वो होगा। हमको कोई किसी ने बोला ऐसा करो तो नहीं होने वाला है, तो वो तो फिर वो किताबों वाली बात होगी, वो रख के बस एग्जाम दे दो, बहुत अच्छे नंबर आ जाएंगे, लेकिन आ जाएंगे क्या करोगे? कुछ नहीं। किसी बोलने से नहीं होता है, तो करना क्या चाहिए? हवाई किले बनाओ, सबके सब हवाई किले बनाओ। You have to build castles in the air. Unless you build castles in the air, how are you going to put them on a drawing board? And how are you going to really build them on the ground? हवाई किले बने। अब देखो, उसमें ये है कि हवाई किले बनाओ और उसको करो, सब कुछ अपने मर्जी से नहीं होने वाला, क्योंकि यहां पे आ जाता है इन्वेंशन, इनोवेशन। हमारा सब्जेक्ट इनोवेशन है, इन्वेंशन नहीं है। हमारे सब्जेक्ट है इनोवेशन, नॉट इन्वेंशन। इन्वेंशन वो उसको बोला जाता है जब टेलीफोन पहली बार आ गया, लेकिन इनोवेशन है योर स्मार्टफोन्स, बिग थिंग। सो आवर सब्जेक्ट इज इनोवेशन, नॉट इन्वेंशन। अब इनोवेशन के बारे में आप क्या सुनना चाहते हो? जब तक आप कुछ बोलोगे नहीं, तब तक मेरे दिमाग में आएगा नहीं कि आपके साथ क्या बातचीत करूं। मुझे इधर बोलना कुछ नहीं है, आप लोगों के साथ बातचीत करना है, क्योंकि आपके दिमाग में जो पैशन जो हुआ है वो प्योर है। वो उस हिसाब से नहीं है कि हाँ ये हमको करना है क्योंकि ये करने से पैसे मिलेंगे, क्योंकि ये इंडस्ट्री ये चाहती है, वो इंडस्ट्री वो चाहती है, तो खाक होने वाला है, नहीं होगा ऐसा। आप क्या चाहते हैं उसके बारे में सोचो, दिल से क्या चाहते हैं। देखो, अगर आपको कुछ काम करना पसंद है वो करते रहो, कीप कंडक्टिंग एक्सपेरिमेंट्स and keep failing because your success lies in that. It is not कि आपने ये किया अच्छा हो गया, अच्छा हो गया, अच्छा हो गया, वो खाक अच्छा हुआ, उसने सीखे क्या? आपको तो पहले ही मालूम था, इसके लिए सब अच्छा हो गया। पहले मालूम होने से कुछ फायदा नहीं है। ऐसी चीजें करो जिसके बारे में आपको कुछ मालूम नहीं, then the challenges will come. Necessity is the mother of invention. But let's not talk about invention now. I would say conflicts is the father of creativity. There has to be conflicts in your mind. Every time there should be a problem. How are you going to solve that problem? That is the most important thing. Now I don't know what to say, what to tell you. If you want to know about my product, I can probably display it in some fashion. I don't know how. I think, but what is the use of going through what experience I have got? I want to get more experience. The only way I can get more experience is through you people. You have got all those requirements and needs in your mind. How to fulfill them is going to be your innovation. Can somebody tell me whether I am on the right track? Do you want to listen to my bullshit or something else that you want me here for? I'll do that. I really don't know. Unless you speak up, I will not know. Is there a way that I can come down and meet you people? Is it allowed by any standard?
Yeah. It is your you can do it.
You are a great. He is a great man. He is allowing me to come and meet you people. I don't know how to do it, but I'll try. Hi. You people are all students? You're also students. Can you help me, one of you, because you can probably translate, what they are saying, what they are not saying. I start with him. He is my co-director, my only friend for so many years. You know how much our friendship is? It is 65 years friendship. Because I'm 70 and when he was born, I was fathering him. Oh, mothering him. Sorry, wrong word to use. I was mothering him. Okay, so now I would like to meet you people. I see so many girls. And what is the percentage we have here? Male, female? Any idea? Almost equal. This shows women of today are really interested in R&D. So what do you want to research? You want to research on creams which will make you look young and good? By all means, come up with something new. Come up with something real. Come up with something that nothing is required. Only thing that's required is do exercise, work, do physical work. There has to be blood circulation in your body. That travels through your brain. It looks like you are agreeing with me. All of you are agreeing with me. But I can see you very expressive about it. It's very good. So tell me something. What exactly you find I'm doing something funny? Not really. I just want to know you people more and more and more. Because all the strength, you're the strength of the country. You're the only thing we have. We have got nothing else. We have got tremendous talent. But the problem is, we are too lazy and we don't come out. We don't have work culture. You see, we see all the Indians who go from here, they are the high rankers abroad in the West. What happens to them here? They are much better, we are much better than those people because the people who cannot face life there has escaped to that place. And here they are toppers. तो हमारे पास क्या नहीं है? केवल वर्क कल्चर नहीं है, बाकी सब कुछ है. डिसिप्लिन करो माइंड को और it starts with your body. You want to look good? The only way you look good if there is blood circulation in your body. You have to do all those exercises. Am I right? Thank you. Anyway, I don't know how to take up more of your time. I don't know what to say. If you give me some leads, maybe I can talk further. I don't know how long I'm supposed to talk. Can you tell me? 1 hour. And how much has happened already? Oh, it's just begun. My God, he wants me to talk about many things. No, I can't let out all my secrets. That's not be good. What do you think? That won't be welcome anyway. Anyway, my friend, he knows me inside out. You know, we've been friends for almost what? I lost count. I don't even know how old he is.
40 years.
Everybody has gone to dictionary. But I want to make friends with you people. Then only I'll remain young. It's all in the mind. You see, age is not a number. Age is how old you think you are. That's it. It's all in the mind. And whatever you have to do for it, do it by all means. Discipline yourself. ऐसे नहीं बोल रहा हूँ कि आप ये काम मत करो, वो काम मत करो. कोई काम अच्छा या बुरा नहीं होता है. बुरी होती है हद. अगर आपने हद क्रॉस कर दिया तो गए काम से. ये लक्ष्मण रेखा ये क्या चल नहीं रहा क्या? सॉरी, चल रहा है? कभी कभी चलता है. तो ये लक्ष्मण रेखा जो है वो क्रॉस नहीं करती. अच्छा काम किस हद तक अच्छा है उतना करना चाहिए. उसके बाद द लॉ ऑफ डिमिनिशिंग रिटर्न्स अप्लाई. क्या करना? फायदा नहीं है इसके आगे करना. जिस हद तक करना है उस तक कर लिया। और बुरा काम जो है, कोई काम बुरा नहीं होता है, तो बुरा काम जो है वो हद के, मेरी हिंदी वीक है, आप जरा करेक्ट करें, हद के बाद, ये हद के पहले वो हद के बाद, कोई ऐसा है हद के बाद, so that's what I'm saying. Yeah. So anyway, you people understand what I'm trying to say, okay? So basically, santulan, yeah, this word is correct, balancing. Life is nothing but a tight rope walk. We just have to balance it. अभी क्या होता है, बैलेंस तो करना पड़ता है, नहीं तो क्या होता है, कभी एक बाजू भारी हो जाता है, कभी ऐसा, कभी वैसा, ऐसा नहीं होना चाहिए. It should be complete संतुलन. अभी हमारा रिलीजन इतना स्ट्रॉन्ग है. Sorry, I am not going by religion. I am very, very strong. But I am taking advantage of what is there. Lord Shiva. We know about Lord Shiva? All of us? Yes, sir. You know? Oh my God. And you know this Bajrangbali? Yes, sir. Bajrangbali Lord Shiva का ही रूप है. और Lord Shiva ने उसको क्यों रखा? क्योंकि वो तो बम बोलेगा मस्ती में. उसको कंट्रोल करने वाला बजरंगबली. बैलेंस. हमको यही करना है, यही सीखना है, बैलेंस करना है. कोई बुरा कोई खराब चीज नहीं है, सब अच्छी है अगर बैलेंस रखो तो जिंदगी में कुछ बुरा कुछ अच्छा ऐसा कुछ नहीं है. किस हद तक करना है, क्यों करना पड़ता है, कभी कभी करना पड़ता है, कभी कभी बच्चे को चाटा मारना पड़ता है, करना पड़ता है तो करना पड़ता है. ठीक है. सॉरी, मैं आप लोग सब बच गया है, लेकिन चाटा मारने आप लोग बहुत सुधर है आप लोगों में. अगर आप लोग ऐसे लेक्चर के लिए आएंगे, रिसर्च एंड डेवलपमेंट यू वांट टू डू, आई वांट टू नो फ्रॉम यू व्हाट एग्जैक्टली यू वांट टू डू. R&D, something, somebody must be having something that you want to do. What do you like? What do you want in life? रूटीन चीज मत बताओ, वो तो सबको ये चाहिए, वो नहीं, कुछ दूसरा, कुछ नया. देखो हमको क्या नयापन देखना है ना. See, what is innovation basically? Something new, new thoughts, maybe new process of doing it. And ultimately what you create, that has to be new. So all these things have to be new. That's what it means, right? लेकिन ये न्यू आएगा कहां से? ये सब पुरानी बातें हैं, कट पेस्ट वाली. नया तो अंदर से आता है. आपको चाहिए क्या, वो सोचो, उसके बारे में सोचो, निकल आएगा कभी ना कभी. एकदम से नहीं निकलता, कभी ऐसे मूड में किसी के साथ कुछ बात करते करते झट से निकल आएगा. लेकिन कुछ तो ख्वाहिश होनी चाहिए ना, बहुत मजबूत ख्वाहिशें होनी चाहिए. ऐसा भी होता है कभी कभी किसके साथ, ऊपर वाला उसको कुछ ऐसा उल्टा सीधा कर देता है कि उसकी हालत बहुत खराब हो जाती है, तो उसके बारे में बहुत कॉन्फ्लिक्ट पैदा होते हैं, तो उसमें से निकलता है, उभरता है, वो भी होता है. लेकिन आप लोग अभी समझ जाओ, ऊपर वाले को क्यों बोलते हो कुछ करो हमारे, समझ जाओ आपको कि क्या चाहिए तुझे. अच्छी अच्छी बात है, जो खराब बात अच्छी बात उससे कोई फर्क नहीं पड़ता है. चाहिए क्या, वो कर सकती हो, कौन सा तरीका उसको करने का. सी, एक तो बात जाहिर है आज की लड़कियों में कि वो मर्दों को जीतना चाहती है, सबकी सब, और बिल्कुल जीतेगी. जितनी शक्ति उनमें है ये, वो हम मर्दों में नहीं. हम अपने आप को मर्द कहलाते हैं, लेकिन कोई लोग हम में से ऐसे हैं जो मर्द कहलाने के लायक है ही नहीं. दुनिया ऐसी चल रही है, क्या कर सकते हैं. मर्द वो होता है जो औरत को देवी समझे, तो वो बिल्कुल मर्द होने के लायक. अथवा चलो मैं इस बात पे अलविदा करूंगा, क्योंकि आप कुछ बोल नहीं रही हैं, कुछ समझ में नहीं आता है आपको क्या क्या बातें बताओ, कैसी बातें बताओ. आपको पूरा उसमें लगे जाऊं calculations and this and all kinds of things. You see, today things are so easy. हमारा जो जमाना था, मैं 70 साल का हूं, हमारा जो जमाना आपको मालूम है क्या था? लॉग टेबल्स, लॉग एंटी लॉग यही करता था। अभी हमने उसको क्वेश्चन का आंसर तो किया, अभी वो एक्यूरेसी के लिए कितना टाइम लगता है वो अरिथमेटिक करने। लॉग टेबल्स, एंटी लॉग, वगैरह, बाद में निकला स्लाइड रूल। वो स्लाइड रूल में ऐसा है कि वो पूरा ध्यान से जरा सा इधर उधर बनाने से तो वैसा। आप लोगों के पास क्या सब है, स्मार्टफोन है, चाहे दो चाहिए उसमें मिल सकता है, पूरी दुनिया मुट्ठी में है। अब with a smartphone you got everything, you got the net, whatever knowledge you want you've got, there is nothing that you don't have. लेकिन क्या चाहिए तुझे, सब मिल जाएगा, रिसर्च करो ना। लेकिन पहले क्या चाहिए वो पैदा करो, उसके बिना क्रिएटिविटी नहीं होगी। अरे ऐसे पैदा करो जिसमें कॉन्फ्लिक्ट हो जाए। मैं आज बहुत इधर लोग होंगे जिसके सामने मैं ऐसे बोल नहीं सकता हूं, लेकिन आपको गप बता रहा हूं, कोई भी कॉन्फ्लिक्ट हो, आप सोचे कि तेरे को ऐसा करना है, लेकिन तेरा मन सोचता नहीं मुझे ऐसा करना, तू अपनी मन की सुन, ये गलती मत करना, हमेशा अपने मन की सुन। मैंने उससे पहले क्या बोला वो किसी ने सुना नहीं, वैसे ही होता चाहिए। चलो भाई, अभी क्या बोलो मुझे समझ में नहीं आया। आप लोग कुछ बोलेंगे नहीं तो क्या मुझे मालूम पड़ेगा कि क्या बोलो। मैं तेरे को ये सब दिखाऊं क्या जाके? हाँ चलो यही बात करो। आपको एक बड़ी कंपनी है जिसका नाम है लार्सन एंड टोब्रो। दे आर इंजीनियरिंग जायंट्स, big company. They are probably almost the best in the world as far as engineering goes. तो मैं जब कॉलेज में था, मुझे एक बिलबोर्ड दिखा उधर, We make what make India proud. तो मैंने हवाई के लिए बनाया, मैं भी क्यों नहीं कर, तो मैं कर बैठा। लेकिन बहुत कुछ किया और हमारी टेक्नोलॉजी दुनिया ने मान ली है अभी। We have got all the endorsement from the West, from the American Society of Mechanical Engineers. They are the authority all over the world for our product, for this type of product what we do. तो ये तो हो चुका है, लेकिन अब मुझे बताना है। देखो व्हाइट स्किन ने मेरे को स्टैंपिंग दे दिया है, अभी तो कुछ प्रॉब्लम नहीं होगा। अब मुझे यहाँ पे सब कुछ बना के सब ठीक कर सकता है। हमारा काम क्या है? देखो इनोवेशन किसको बोलते हैं? इनोवेशन फॉर बेटरमेंट। इनोवेशन हालांकि सब तरीके से हो सकता है, बट फॉर द बेटरमेंट ऑफ द सोसाइटी। Now talking about the betterment of the society, in one aspect, I'm so sorry because this place is too narrow for me to walk, but anyway, I'll continue walking here. And of course there are many students there also. I don't know where to go. So I think I should go back there and learn to behave myself. Yes. Is there a pointer? You got a pointer? How does it work? Huh? तो मैं तो गलत नहीं बोलता। मैंने मुझे करेक्ट कर दूंगी क्योंकि मुझे मालूम नहीं पड़ता मैं क्या गलत करता है। हाँ? जैसे गलत हो हाँ ये ठीक है, लेकिन अभी क्या करें? ये नहीं सकते, ये पीछे का I don't know, it's senseless for me to present something, लेकिन मैं एक काम करूंगा, आपको जरा बताऊंगा क्या है ये। आप लोग इंजीनियरिंग के स्टूडेंट हैं सबके सब? Some of you are from mechanical engineering? Sorry? Very nice. I think I left my water somewhere. वो माइंड नहीं करेगा। See, what is this whole world about, universe about? The laws of universe. The reactions are taking place everywhere. Atom, molecules, reactions are there. Do you agree? The reaction, there is a reaction in your body taking place when you eat your food, and that's reaction is everywhere. Am I right? Now, any reaction is either exothermic or endothermic in nature. Am I right? I don't have to explain, you people know that everything. So, either the heat is generated or the heat is needed. We provide that heat because we manufacture heat exchangers. We exchange that heat. Now, heat exchangers can be used about anywhere. The requirement is almost anything, because as I told you, any reaction, whether even when you're running a car, your radiator is required to cool the engine. So, heat exchangers are just about anywhere, whether it's the cold storage or anything, or any reactions in all the chemical plants and nuclear. How do you, after there's a nuclear, huge amount of heat is energy that's generated, what captures the energy? It's a heat exchanger, it's a heat and mass transfer. That is how your turbines are run, and that's how you get your electricity. So it's all about heat exchanger. The whole world is all about heat exchanger. That is why I have stuck to this line for quite some time. I'm quite bored of it now. I'm getting into other things, but so far because one thing is there, especially in the shell and tube heat exchanger. There are so many variations, so many innovations that you can still do. It's unlimited. So I have not left this field. As I have मटन, चिकन, जहां का भी खाओगे तो सरीका ही होगा। लेकिन मच्छी ऐसी चीज है कि किस्म की है। दरिया की मच्छी, यहाँ की मच्छी, डेल्टा रीजन की मच्छी, उस जगह की मच्छी, उधर की मच्छी, बहुत किस्म की मच्छियां हैं। तो अपने शेल हीट एक्सचेंजर में भी इतनी वेरिएशन है, तो ये बहुत मजा आता है। इसके लिए हम अभी तक दूसरी लाइन पे घुसे हुए हैं, ये लोग छोड़ते भी नहीं है। तो ऐसा है। तो उसमें क्या बताना है आपको कि ये नॉर्मल तरीके का हीट एक्सचेंजर था, जिसकी जो बोल्ट है इतने बड़े हैं, क्योंकि हाई प्रेशर, हाई टेम्परेचर, corrosive service, hazardous service, and dirty service. So when I say dirty service, what does it mean? Dirty service means you have to keep cleaning up your equipment, because otherwise the dirt is going to clog it. So what kind of heat transfer will take place if there's dirt everywhere? You see, heat transfer, how does it take place basically? One side fluid, the other side fluid, they're not to mix, but they have to be connected somehow, somehow they have to be connected so that they can dissipate heat or absorb heat. It's simple. So that is how heat transfer takes place. So essentially there is tube side and there is shell side. Okay, the shell side, the inlet is here, the outlet is here, here the tube side will go through the tubes. This is where the heat transfer will take place. When one fluid is going inside the tube, the other fluid is outside the tubes, that is where the heat transfer takes place. Because that's only a thin metal which is dividing. Am I right? Do you understand what I am saying? Or am I talking all rubbish? Because I want to know, क्योंकि मैं जो भी सवाल पूछोगे मैं उनका जवाब दूंगा, लेकिन आप समझ लो मैं क्या बोलूँगा. है कोई सवाल? Heat transfer. I told you heat transfer is the most essential thing. That you agree? That anything that happens, any reaction, heat transfer equipments are required. Heat transfer is taking place in your body. You have to eat some food to develop some warmth in your body so that you can, the freezing temperature outside, you can bring it down. Your temperature inside remains normal. So your human body is nothing but a heat transfer equipment. So that's how a heat transfer is. So do you people understand what I am talking about first? Heat transfer. I can see people nodding, yes, 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 yes. But nobody is saying, yeah, of course we understand. What about you people? Do you understand what I am talking about, heat transfer equipment? बहुत बोरिंग है क्या? बोरिंग से मुझे भी बहुत डर लगता है. कोई चीज बोरिंग होती है तो एकदम मन में घुसता ही नहीं कभी भी.
Anybody from mechanical engineering?
नहीं, मैं तो मैकेनिकल इंजीनियरिंग की बातें नहीं कर रहा हूँ. मैं तो केवल हकीकत बोल रहा हूँ कि जिंदगी की हकीकत की बात कर रहा हूँ कि हीट ट्रांसफर के बिना कुछ हो ही नहीं सकता है. ये तो आप लोग मान रहे हैं सब लोग, लेकिन कोई आप लोग समझते हैं ये बात? हाँ, कि हीट ट्रांसफर की जरूरत है इसमें. अब रिफाइनरी में जब हीट ट्रांसफर करना पड़ता है तो डर्टी सर्विस मैंने इसके लिए बोला क्योंकि रिफाइनरी के जो हीट एक्सचेंजर होते हैं और फर्टिलाइजर प्लांट्स के जो हीट एक्सचेंजर होते हैं वो ही सबसे खतरनाक, सबसे ज्यादा न्यूसेंस वैल्यू उनमें होता है. That has got the maximum nuisance value. The reason being the service is dirty, and because it's dirty you have to open it up to service it. That is where the engineering challenge lies. All the innovation has to take place there. Because it's basically a gasket. Here there's a gasket, here there's a gasket. Now, because of high pressure and temperature, these boards can be 6 inches in diameter. And so long because ये सब thicknesses बहुत ज़्यादा है. ये बहुत लंबा है, ये बहुत flanges are very very heavy. तो उसको टाइट करना पड़ता है. Either there is a gasket here. When this gets tightened, the gasket will get tightened, and that's the only way it will not leak out. It will be leak-proof. The joints are going to be leak-proof. You understand? Now this is going to cost a lot of money. Plus, how will you maintain it? Maintenance will take so much time. It will take away many days of the shutdown of the refinery, thereby rendering a lot of losses. So this is another version of screw plant, where the weight goes on down almost, let's say by 30-40%, and very easy to maintain because there are no such big boards. So this is what we have done. Now in this, when other companies did, there was a lot of bell mounting, and that is why the jam would take place, and it was not possible to service at all. So we have licked that problem. And we have licked one more problem, that there is no leakage between the shell side and tube side, which is generally the practice. So I went through this a little quickly, so not to bore you people. Basically, it's that. Now, what more you want to know? Should I go into details of this? Is it necessary? Anybody interested in going through details of this? I don't want to waste your time. Time is very, very precious. So let me not get into all this. I'll just tell you that in order to make that happen, I did a lot of experiments. So I did experiments with very tiny ones. You know, you can see all tiny, tiny parts. Is it clear? The view is clear? Can you see? So there are very, very tiny, tiny parts for this. It's a prototype. It's a very small one, which I experimented. And I took it to very high pressures and wanted to destroy it. And what would save it? So the shrink-fitting ring of our design that we have modified, innovated, that is serving everywhere through a lot of refineries throughout the world. And we have got a good name for this. So this is what I wanted to show you. This is how it looks where people came to see. I am there. That's me. That's my partner. And that is the white skin. Because white skin has to approve it. This. So it has been approved. Those are Japanese. This is Japanese. Who has also approved it. That's some Toyo, some big company. And the earlier one was Chevron. This is what it looks like, this tank, these two exchanges there, this and this. And this is just to tell you, in the conventional way, the weights are going to be very, too much high and this is much smaller. So we have done so much of hard work for the government, for the country. We have brought down the prices from something like 15 crores of one equipment to something like 7, and now we brought it down further to 5 crores. That is the cost of the equipment. Earlier it was very high because it was just one company doing it and they just quoted whatever price they wanted. I don't have to tell you. Anyway, I think we are done with the tough part. Now, do you have a feeling that I bored everybody? No. That's very good feeling. Sure. Thank you. I would like to meet you again. I would definitely like to meet you people again because I feel young when I meet young people. And I want to work along with you people because today we have the opportunity. The growth rate is going to go. If it grows like China, you know how much work we have to do and everything comes from innovation. Today, with the slogans that we hear, make in India, innovate in India, skill in it. We've never heard these slogans before. तो ये किसको करना है? ये तो गवर्नमेंट ने बता दिया, ये सबसे इंपॉर्टेंट चीज है। करना तो हम लोगों का है ना। और आपका जो ये इंस्टीट्यूट है, इतना जो कर रहा है, मैंने कहीं देखा नहीं है ऐसी मिसाल कि इतना R&D पे महत्व दिया गया है यहाँ पे। कोई ऐसी जगह नहीं है जो मैंने देखी है अभी जिसमें इतना महत्व दिया है। तो मेरी तो ये हो ही ख्वाहिश कि ये जगह इतनी उभरे और आप लोग उसमें हो इस जगह को उभरने वाले। तो आपके बाद में जो आने हैं वाले वो लोग भी होशियार हो जाए कि हमारे कंट्री में इतना टैलेंट है और हम लोग टेक्नोलॉजी बाहर से खरीदते हैं। ये तो हम लोगों के लिए शर्म की बात है, कितना टैलेंट है हम लोगों को। Please do that. Thank you very much. Thank you, all of you.
I'm sure after listening to Sir, you must be having some questions. A question from there? Yeah, sure.
Kindly come forward.
देखो मुझे कोई सवाल का जवाब मालूम नहीं होगा तो मैं सीधा सीधा बोलूंगा कि मुझे मालूम नहीं, है ना?
Good morning, sir.
गुड मॉर्निंग.
My name is Nitya Jha. And sir, I have a question that the topic is about sustainable innovation. Thank you very much.
सॉरी.
The topic of discussion here is about sustainable innovation. But in this era, in this materialistic era, we all care about the job security and etc. So we, the young people, are really focused on our job security of protecting our future. So what happens is that we mainly concentrate on earning money. So how is it without any kind of industrial exposure, how can we even think of some kind of innovation?
You have said so many things in just few sentences. For me to answer is not going to be so easy, but I am going to definitely try because the questions are very, very relevant.
And
Your
sir,
questions are so relevant and so powerful that it really hits you. Yes, we have to do innovation, but nobody is giving any importance to innovation. That is why I am complimenting this place where it is giving importance to innovation. Innovation should be such that it should be definitely, you should be able to make your living out of it. Most definitely. And then one fine day when you get a great idea, it should really go. But to start with, you have to make a living. Otherwise, how will you survive?
exactly, sir.
And the other thing that you were talking about is students, unless they have the exposure.
Yes, sir. Industry.
See what should happen everywhere. I've been telling everybody this. Unless there is at least 1 year for vocational training in the industry of your choice, which your institution has to provide, it's of no meaning. That only will give you the graduation. Otherwise, you should not be a graduate. You have to have exposure to what you want to do, what you want, and the institution has to provide. And the industry should be available for that. Mine is. I am doing that all the time. All of you are invited. Anybody who thinks any of our products of some interest to you, please.
Any more?
You will be getting stipend. Government is also giving you stipend. तो पैसा होगा, फिर आप रिसर्च करो. और मैं ये भी चाहता हूँ कि मैं भी कोई तरीके से थोड़ा सा पैसा कमा लूं. बहुत टाइम से हमारा घुसा हुआ है पैसा बहुत जगह पे. मैं R&D में इन्वेस्ट करना चाहता हूँ. And that is only having R&D people over there and giving them all the facilities to do the work, and they will be given this kind of stipend because their work is going to be productive. It is going to be sold also. That is going to be my job, to see that whatever they do is sold. Okay, and we have enough revenue to give you people good salaries, and that is what I want to do. So that आप दिल से काम करें. फिर देखो उसका नतीजा क्या होता है, फिर देखो कंट्री कहाँ जाती है. चलो, थैंक यू वेरी मच.
Thank you, sir. Thank you, sir.
Further proceeding with the program, I would like to call Dr. K. Subramanian, Executive Director, Power Gear Limited. He has obtained his PhD from Stanford University in Electrical Engineering with a specialization in Micro Electromechanical Systems or MEMS.
Sir is currently CEO and Head of R&D at Power Gear Limited, MEPZ, Chennai, where he works on implementing several novel technologies in energy and other sectors. He previously worked at GE's Global Research Center at New York.
Sir has filed more than 50 patent applications in his field. He managed a large program on MEMS at GE and received 2 prestigious awards for his research. One of them, the Hull Award, is presented to early career researchers at GE Global Research.
And the other award, the Whitney Technical Achievement Award, is for a project that is viewed as a potential market game changer. Sir, is a Six Sigma black belt. The current R&D initiative at PowerGear aims to showcase innovative talents of India to the world.
Sir, the stage is all yours. Kindly come and share your views with us. Please give them a huge round of applause.
Is this mic working? It is, right? Because the speaker made such a huge noise when I was passing by. Thank you for the introduction. And thank you for the really nice talk right before me so that the audience was energized. So now hopefully everyone will open up, right? And speak up. Maybe I should make you speak up. We'll just wait for that to get going then. Just a second. Make some help. Yeah. I need a volunteer to get up and read that sentence. Any volunteers? Yes.
The anions and cations are in motion.
Okay, little louder please.
The anions and cations are in motion.
Okay, what does that, thank you. What does that mean to you? Any other volunteers? Come on, I'm sure you guys have learned something about batteries, right? So what's an anion? What's a cation? Please.
So the anions are the negative charges and the
Okay.
cations are the positive ones.
Okay, so one of them is a negative ion and the other one is a positive ion, right? And they are in motion, correct? So why are they in motion? Because when you charge a battery, the one ion goes from there to there. When you discharge a battery, it goes the other way, correct? So this means nothing, okay? This has no relevance to the talk. I just wanted to display this as a very interesting example of a student who, when he saw this exact sentence, you know how he read it? So you read it correctly, thank you. He said, the anions and cations are in motion. So he thought that was also an ion. So that is the unfortunate state of education in many places. And the second part of that joke is he actually got full marks for writing that answer. Right? Because he learned it exactly the way it was written. He understood it differently. He wrote it exactly the way it was written and he got the marks for it. So, yeah. Before I get to this, and thanks for the wonderful introduction, I'll just introduce what I do in about 2 minutes, and then I'll get on to the talk. So I work for this company called PowerGear. I used to spend most of my career in research at the General Electric company in the US. So here, this is basically an electrical engineering company. We deal in power products and so on. So within that company, I help the R&D division. So we have a very noble intention. We want to show the world that we Indians can outsource or perform outsourced work at the highest level. So outsourcing started, as you know, with data entry and IT services, medical services, etc. We've been climbing up the value chain in outsourcing. But we want to show the world that we can be a team of scientists, a team of innovators. We can actually deliver innovation to the world, right? So we have an R&D business where we actually take on research, innovation kind of projects that we execute for several, primarily industrial clients, right? So we actually maintain a team of full-time scientists. We maintain a team of labs, right? We deliver innovation, right? So it's a very unique and different business model, and it's an uphill battle for us to prove that something at the level of innovation can actually be outsourced and can be performed effectively through timelines and deliverables, but it happens, it works. Right? Okay, so let's make this talk a little more interesting, and thank you for interacting. So I'll just before I get to the main topic, I will I'll try and engage you a little bit, right? So you might have heard about the word in philosophy called Vedanta. Have people heard about it? Anybody knows what it means? Vedanta, V-E-D-A-N-T-A. Any volunteers? I'll give you a clue. It's actually two words. Okay, one word is Veda, right? The other word is Ant. Ant is end. Veda is? Yeah, but Veda actually means knowledge, right? Veda means knowledge, and Ant is end. So what is Vedanta? It's a very funny word, right? It says it's the end of knowledge. So it's a confusing word because does knowledge have an end? It doesn't, right? So Vedanta has many.
What is given in the end is what you have to think of.
Yes.
In the end, what is given?
Right.
In the end, summary is given. Tell you what is the premise. What is given is what is the premise. वेदांत इतने हैं जब सब पढ़ो उसका समरी जो है वो दिया है. सो इट गिव्स यू बस उतना पढ़ने से समझ जाने से सब कुछ हो जाएगा. उसी को पढ़ लो, वेदांत को ही पढ़ लो, और कुछ पढ़ने की जरूरत नहीं है. लेकिन वेदांत को पढ़ो और समझो, भगवत गीता को पढ़ो और समझो. Sorry, I was
No problem.
inspired by what you said. Very inspired.
Thank you. So let me elaborate on that a little bit. So I'm not going to talk about philosophy here. Okay, so I promise it's going to be interesting. So Vedanta, end of knowledge, but knowledge is infinite, right? So maybe Vedanta is another word for infinity, right? Because we are in the pursuit of infinity, we are in pursuit of knowledge, and we know that the more we learn, the more we learn that we don't know, right? So it is infinity in a sense, right? And out of this infinity, we have learned a few things. Some amount of knowledge has been captured. And that does not have to be reinvented, right? And there's a lot of knowledge that has not been captured. That's where innovation is, right? And how do you tap into that knowledge? How do you tap into the knowledge that's being captured? That's your textbooks, that's the internet. And there are many, many examples. I don't know how many of you have heard, there's a wonderful tool. It's called TRIZ, T-R-I-Z, right? It's a Russian tool. It's an acronym. It stands for Theory of Inventive Problem Solving. So if you write those words out in Russian, you have TRIZ, right? So what they did is they just did a very simple thing. They just went and looked at all the inventions that happened today. They started compiling all that into a database. They organized those inventions. They made it searchable, so that you don't have to really reinvent the wheel anymore, right? So what you do is when you come up with you get stuck somewhere when you're designing something. It's called an engineering contradiction. So when you're engineering some part, you usually come up with some contradiction. So you go to that TRIZ tool, you look up that contradiction, and I'll give you some examples, right? Look up that contradiction. You see where, so usually in engineering, for example, you're trying to make something stronger, usually it becomes heavier, right? So if you come up with a contradiction, if you want it strong and light, it's a contradiction, right? So classic mechanical engineering problem. So when you come up with that contradiction, you look up in the tool and it simply guides you to a page number that tells you how all people have solved that problem of making something strong and light at the same time. So simple way to capture what all has been invented, right? I'll throw a couple of problems out at you, simple problems, so that you can start practicing innovation right here today in this room, right? So there's a classic problem that when you take a TRIZ class, right? So you have a rubber hose, right? So what you use to water the garden. It's a rubber hose that carries water. And there's a problem where you want to drill holes into that rubber hose. You need a drilling machine that can drill holes into that hose. Now the classic problem of drilling, I'm sure you guys have gone through workshops, right? So you've done some amount of workshop work, carpentry, drilling, etc. So when you want to drill something, it's very hard to drill into a very soft object. It's very difficult, generally speaking, right? So you need something hard like metal, and then you can drill a nicely controlled, very tight tolerance, fine hole in it, right? I'm talking in loose terms here, but I want to keep it like that. So how do you drill a hole into rubber, right? So you want to drill a hole into it, but it has to be, the material has to be hard for you to drill a hole into it, drill a precisely controlled hole. But rubber is a soft material. So how do you drill a hole into rubber? Any ideas?
Freeze the rubber, it will become hard and then you can get.
Wonderful. See, that is a great solution, because when you, and again, I'm not trying to market this tool, but it's an interesting tool. So when you apply, ask this tool this problem, it will ask you back, does it have to be hard and soft at the same time? Right? So it will ask you back that question, which prompts you to think. So it is soft when you actually are using that rubber goes through water your mouth. At that time it has to be soft. But in the factory, when you are machining that hole, at that time it may not be soft, right? So it gives you these principles, which tells you can do things which are separated in time. So when you're drilling the hole, you make it hard. After that, you make it soft, use it in the application. Many examples like this. Okay, another simple example. When you have narrow roads like we do in India, right? Of course, now we have nice highways, but even when you drive on the highways, finally you have to turn into the city somewhere, right? And if you have narrow roads, and let's say you have a large truck, right? The truck has to be big because it has to carry a lot of stuff, and it has to be small because it has to negotiate a narrow turn. It goes big road into small, tight turn, right? So how do you solve this contradiction? Something has to be big and it has to be small. Any ideas? Little bit participation from this side of the audience also. Any ideas? Yes.
Length could be decreased and length could be.
Okay, still if the length is long, so you have to turn like this, right? So it's going to hit something. So the turning radius is tight, then.
You can divide it into parts.
So great answer, right? So I think the directors should be happy. I think there's a lot of innovation going on right here. So what is, these are all old problems that have been solved, but again, you should not be resolving them, right? So when you have a long thing that has to be short at the same time, the easy answer is to make it into short segments where the total length is long. That's what a train is, right? You make it into short pieces, the total length of the train is huge, but it can actually turn tight turns, right? Many examples. For example, there are other principles that tell you that you can actually gain by eliminating parts in systems, right? And there are, a simple example is a toothbrush, right? It has a stick, has some bristles in it, right? What can you eliminate? Can you make a toothbrush better? Simplest example, right? Everybody uses it every day. And that somebody innovated. Okay? So they eliminated that stick. They had just had that bristle. They had a small straw, you put your finger. So that stick was eliminated. This finger becomes the stick. You have a stick, right, in your body. Right? Just to show that even at that level, a toothbrush, you would think that all the innovation that has to happen in a toothbrush has already happened. But even at that level, you can innovate. Right? So innovation is not coming up with the next greatest gadget.
This was the
So
starting point anyway.
Yes.
This was the starting point anyway.
Exactly. So we've come back full
We
circle.
used to cleaning our teeth with a finger.
Yeah. So only now you have a list of set of bristles.
Very nice.
Another example, in Western countries, where you don't hang clothes outside, they usually have a washing machine and a dryer, right? And here some people do, but in mostly India we have so much sun that it would be criminal to have a dryer, right? So solar drying which is what we do, right, by hanging clothes outside. That is a great solution. Anyway, so in some countries they do have the necessity to have a dryer, which means you wash your clothes in the washing machine, take it out, put it into another machine, it spins, tumbles the clothes, blows hot air, and finally you get totally dry clothes, as if you put it out in the sun. Okay? So this dryer has been around for a long time. There's nothing very fancy about this. It's a drum that keeps slowly rotating. The clothes are tumbling, hot air is blown through the clothes. Then finally, if you wait long enough, the clothes are dry. Right? It was a little problem. A lot of people were making this dryer. And it became what's called a commodity in parlance, marketplace parlance, which means that too many players, like so many people making soaps, it's very hard to differentiate one soap from the other. Very, very small differences. Right? Like this, so many people were making dryers, everything almost had the same set of features. So the price kept going down and everybody was selling it at almost the same price. Nobody could make much profit. Then one day somebody came up with an innovation. Any ideas what it can be? And I'll tell you what the problem is so that you can think about the innovation. The problem is a dryer is extremely energy intensive. Right? It has to blow hot air, so it needs a heater. Right? And it's part of the problem. The real problem is, as you're drying it, you don't really know what is the end point. You don't know when your clothes are all dry. Right? So what you normally do is what maybe you should be running it for 45 minutes, you run it for half an hour extra. So that you're sure all the clothes are dry. Because it's a pain to go and check and see if the cloth is dry and then turn it on again. It's a waste of your time. Right? You're doing something, watching TV maybe, who knows. Right? So this is the problem. How do you know that your clothes are dry inside the dryer? Right? And washing machine also, if you think about it, you don't know that your clothes are clean. It just goes through the process and you hope it is clean. Okay? That nobody has solved yet. But here, how do you know that the clothes are dry? Any ideas?
Definitely you people have the idea. Just think.
Sorry.
Just think.
Do you need a mic?
So the weight will get reduced of the clothes. Dry clothes will be heavier.
Good one, yeah.
And the lighter ones will be dry. So we
Okay.
can judge it that whether it is dried or not.
Yeah, so that's a good idea. Little bit hard to implement because the starting weight may vary. You may put 5 kg, you may put 5.5 kg, it may vary a little bit. Right? So you don't know, there may not be a very precise method to find out if your clothes are bone dry. Right? Yeah.
We can check the moisture content of the clothes.
How do you do that?
By sensors.
Okay. Somebody else, good one. I'm just giving another opportunity. Somebody follow that thought and tell me how you will do it.
Sir, moisturizing sensor.
Okay, how do you're not going to paste the sensor on your shirt, right?
No, sir, that's not.
So go one step further. How will you do that? Yeah. If you raise your hand, I'm going to ask you to stand up.
We have to put the sensor in the machine.
Okay. Where, what are you sensing?
The moisture content
Of
the air in the
of the air. That's a great one. So that's what they did. That was the solution. See, now just the fact that I articulated the problem to you, you're waving me like 2 or 3 solutions right on the table. Right? So that's the amazing thing about innovation. So if you just get a big enough group of people who are all excited about this, you will start innovating. It's not that hard at all. Right? So they actually put what's called a humidity sensor, which monitors the humidity of the air inside the drum, which is effectively the same thing that you guys said. Right? So the air is very humid when it starts tumbling. So when the humidity goes below a certain number, They could calibrate it and say, okay, at this level, the clothes are dry. And that guy who made that dryer with that humidity sensor could make a lot of money, because the money is one part, but that innovation is what helped him sell that product. It's differentiated his product from other competitors. Right? Okay. Another topic. People like to watch movies? Why? I'm not going to stop, right? It's like a child. The child will keep asking you why. Right? If you talk to a child, he'll ask you, keep on asking you why. I'm going to keep that habit going. So let's go deep into it. Let's say you were to create an algorithm which predicts whether a movie is going to succeed or fail. Okay? I'm just expressing a simple question in terms of a problem, business problem, right? So you're in charge, you're running a company, somebody's made a movie, they come and give it to you, just going to be released next week. You tell me how much money it's going to make. Is it going to be a flop or a hit? And if you actually have a company like this which can predict, you will be a multi-billionaire, right? So let's see, let's innovate right now. Let's figure out what it is that makes a movie hit. I'm sure this is an interesting topic, right? So
very relevant, very interesting. Perfect topic.
Yeah. So please, ideas. So just tell me what inspires you. Will you pick an example? What did you like about it? What made the movie work? Raise hands. Yeah, stories. Okay. Then music. Okay. Suspense. Did I miss something? Stories, music, suspense. Star power. Okay. Okay. Grandeur. Right? Okay. What else? We already have 5 criteria now. Okay. Innovation. Okay. That maybe is part of story and music and all that. So you want an innovative story, innovative music.
New technology.
Technology, special effects, if I can translate that, right? Okay, promotion, controversies, trailers. Okay, let's stop there. So, certain people like good stories, some people like good music, some people like controversial topics, right? Some people like special effects. Action, maybe nobody said action, but some people like action movies, right? Let me go one step further and ask you. Let's take songs, right? If a movie only had good songs, would it still work?
No, sir.
It won't. Okay. So this is not the full picture, right? So if, let's say the songs are great, that's not enough, right? What else do you need? Okay, you can't have everything. So that's what is called masala, right? You need the right combination of spices, but not any combination of spices, right? And Indian movies especially thrive on masala elements. And these are all, you can call these masala elements, right? And you need them cooked in the right combination. Okay. And how do you quantify that? You have to quantify it, because if you're so vague, then you can't really predict whether the movie is going to succeed or fail. Right? Is right? So we got a few criteria. I'm going to summarize what we discussed so far. We got a few criteria, but we decided that a single criterion is not enough. You can't have all the criteria either. That will be too much masala. Stomach upset, right? Right? So how do you, somebody help me crystallize this and tell me what.
So majority of, we will go to the majority and we will see that majority of people wants, what kind of content they want, what features they want, and we will make.
Yeah, but you just saw this audience, the opinion was so diverse. You never tell what the majority of
But
people
one
want,
person
right?
said only one feature, na. If I said like music, but I also like content, and I also like the star cut. So I have 3 features which I like. Everybody have a range of variety, na. Not only one thing. If I like fruit, I don't say I like only grapes. I will say I like grapes, banana, and strawberries, na.
Correct.
So we have a range. We will focus on the range and we will target the majority.
Okay. Okay, good. Thank you. Anything else? Any other opinions? Okay, so let me try and add something to this. So, you can add sugar to butter, it will taste good. To mix sugar and salt, maybe, may not be, right? So, sugar and butter intersect well, right? Sugar and salt maybe not so well. Maybe in very few cases. Right? So maybe the key word is intersection. Maybe the key word is how these elements intersect in the movie. Right? So if you have songs and story, if the songs intersect well with the story, then maybe you have a winner. Right? So maybe it's not the individual elements, but it is how these elements interact. Right? So let's take some examples whether this is true. So that if you go back to the 80s, they had song and story, right? And in the 90s, they had maybe good cinematography intersecting with story and song, because you had wonderful picturization of these things. Right? And if you go to the 2000s, they have more intersecting elements. Right? So they may have story, cinematography, special effects, and action. So you see the progression? How the industry, consciously or subconsciously, I don't know, is bringing in more and more intersections. Right? What did Jackie Chan do? He intersected action and comedy. Right? Because Chinese movies are only doing action. And that's saturated. But when he intersected action and comedy, and that they had to blend with, then he had a winner. Right? What did Life of Pi do? It intersected philosophy and special effects. Very different intersection, which nobody had heard of. Right? So, that's what the industry is looking for. The industry is looking for innovation skills that intersect disciplines. Right? And that is truly what works. So there's a bunch of mechanical engineers here, a bunch of electrical engineers, and I don't know what else. But all wrong answers. Right? What we're looking for is a mechanical engineer who knows electrical engineering. Right? And who can intersect. Because that's where innovation lies. A lot of innovation has happened in individual disciplines. Okay? And today that is the saying, innovation happens at the intersection of disciplines. So when two people of two different disciplines come together and actually talk, it's very hard to make people talk in many industries. And then a lot of sparks will fly, new ideas will come up. Right? So if you yourself know multiple disciplines, then you are a very marketable person in terms of innovation. Marketable not just in terms of money.
I second you so much, I can't tell you here. You see, हमें बोला जाता है, be master of something, don't be jack of all trades. What he is saying is just the opposite. मास्टर तो आप बन ही नहीं सकते हो. मास्टर तो एक ही है. मास्टर आप कैसे बनोगे? So why not become jack of all trades? It's only when you know so much can you be able to do the job the best way. Variety तो चाहिए. Variety is the essence of life. You love variety. कभी ऐसा करो, कभी ये करो, सब करो. बहुत फायदा होता है. Thank you. You have inspired me too much.
Thank you. Never mind. With that in mind, I will show you a little bit of technology. right? I don't want to be all philosophical, so that you leave this auditorium with some technology, some inspiration. And as Sir said, you have to be jack of all arts. It's a fact. And you have to be jack of all arts and master of at least one. Right? So that's the way things work today.
वो सबको तो बहुत कुछ चाहिए, ये भी चाहिए, वो भी चाहिए, सब इतना हम लोग कहाँ से लाएं? जैक ऑफ ऑल ट्रेड्स हो गया, बहुत हो गया.
Okay, how many people have heard of MEMS? AMS? At least a few people. You raised your hand or? Yeah. Anybody else? If not, I'll give you a little bit of an introduction. Right? So I'm highlighting this because this is specifically a multidisciplinary topic. Right? And I got my bachelor's in mechanical and master's and PhD in electrical because I wanted to do something multidisciplinary.
That's a great thing.
So this field is micro electromechanical systems. Micro, it is on the size of microns. So micron is 1,000th of a millimeter. Right? So this is the technology of building mechanical parts which are literally microns in size. So to give you a size comparison, the human hair is about 50 to 100 microns wide thickness. Right? So this is 1/50th to 100th the width of a human hair, and you're making mechanical moving parts on that scale. Right? This technology is not new, it's been around for about 30 years. A lot of you may be using it without knowing that it is actually micromechanics. Right? Micro electromechanical, so these are fundamentally mechanical parts but have also an electrical function. There are many examples. To take a simple capacitor, 2 plates and a gap, right? The quantity we call capacitance is an electrical quantity. But if you look at the equation for capacitance, epsilon A by D, A, D, everything is mechanical. Area, gap and all. The equation for capacitance is nothing electrical, literally. Right? So that is at heart an electromechanical device. Because by mechanically moving the plates, you put vary an electrical parameter called capacitance. Right? In fact, that is one way that is used to make sensors. By moving plates and changing the capacitance, you actually sense it. Right? Electromechanical systems. I'm showing 2 examples. I hope everybody can see it. 2 of these are very consumer level examples, so I think you'll identify. So one of them, the top is what analog devices makes. It's called an accelerometer. An accelerometer measures acceleration. Right? Acceleration is literally force, right? Because always you have a mass, so acceleration is force. So how does it measure acceleration? If you think about it, a silicon chip, right, which typically has electronic circuits inside, is very good at logic, processing, computations and so on. But it is not good at interacting with its environment. Because the world is mechanical, chemical, biological, etc. And if you want to sense something that's going on in the world, you have to have a chip that is at heart mechanical, chemical, biological, etc. Right? So a silicon chip with electronic circuits on it does not feel acceleration. Something that feels acceleration is what's inside that chip, which is as simple as a weight hanging on a spring. It actually has a weight hanging on a spring on that chip. So when you have a weight hanging on a spring, when you accelerate, decelerate, you feel that jolt, and that weight moves, and that movement is converted to an electrical signal. So these chips are mechanical chips, which convert the mechanical quantity to electrical. Right? Another example is what is probably in this projector. It's called a digital light processor, or DLP. It's also called a DMD, digital micromirror device. Right? What's inside that chip is zoomed in and shown in that little inset, that place. So you see a lot of small rectangles. Can people see everything from there? And you see a funny thing there, which I'll come to later. But you ignore that. So all these small rectangles, each rectangle is a mirror. Okay? And each mirror is mounted on a spring. A seesaw kind of, it's called a torsion spring. So it's like a seesaw, it can twist and move this way there. Right? And under each mirror and spring is a motor. Okay? So really a motor. So it's an electromechanical system. Motor is electromechanical, right? So if you take a typical screen resolution, 1024 by 768, today it's much higher. But let's take that number. Multiply 1024 and 768. You get roughly 1 million. 1000 into 1000, 1 million. Right? So that is about 1 million pixels in a screen of this size. Right? Or even any computer monitor or a TV, what at least 1 million pixels are there today. Right? And this chip has one mirror for every pixel. So it has 1 million mirrors, million motors, million springs sitting inside that chip, all mechanical, all of them working simultaneously. Right? So it's a miracle, literally. So this technology, in a sense, allows you to achieve what is hard or impossible to achieve with conventional mechanical engineering. Right? And these are made using silicon electronics technology by printing, lithography, chemical etching and so on, not by conventional machining and assembly. Right? And the way it works is these mirrors can move like a seesaw, and if it moves the light towards the screen, one angle, it is a bright pixel. If it moves it away from the screen, it is a dark pixel. Not only that, this actually moves at 100 kilohertz. 100,000 times a second it is seesawing. Right? So the number of times within that second it is shining that light on the screen tells you how bright that pixel is. Then there are many ways to create color and so on. But imagine a mechanical system running at 100,000 cycles a second for perhaps 20 years. What is the fatigue like? You guys are familiar with fatigue? Right? I'm sure you are. So, fatigue life is incredible. These things literally have infinite life. Right? And why? Because we actually make it with extremely special materials which are not conventionally accessible for normal mechanical systems. And you can actually make these things. So if you calculate the numbers, you're into trillions of cycles. Right? And not only that, you're making a chip with 1 million mirrors sitting on it and using it for projection. And the human eye is so good that in the entire screen, even if one pixel is dark, if it is missing, we will detect it. Right? So our eye is so good. So the process yield has to be 100%. You can't have 1 out of 1 million not working. So they achieve those kinds of yields and the kind of reliability which is how many cycles. Right? So such incredible things are possible by marrying conventional silicon technology, applying it to mechanical engineering, which is not what it was conceived for. Right? So that is multidisciplinary. Right?
Yeah, you referred to me regarding fatigue, and I should be knowing, but at that very moment I was feeling so fatigued myself. I only thought about my body and how fatigued. We all get fatigued. So we have to. What does happen when a metal gets fatigued? What do? We heat treat it. Hello, sorry. When a metal is fatigued, what do? You heat treat it. You stress relieve it. Human body is also like that. Human mind is also like, we need some stress relief. We need some jokes and this and that to enjoy. We stress relief. Something we have to do in order to continue. So I was thinking about that fatigue.
So I'm just going to spend 3-4 slides on this. Because we can delve deep into MEMS and there's so much in it. So run you through this list so that it triggers your imagination, right? So why do people miniaturize mechanical systems? So that's the list here. So the first point is miniaturization, for the sake of miniaturization, because sometimes you just don't have space. You need to pack something in a very, very small space, right? You need a sensor built into your cell phone, it has to be small, right? So if you have to miniaturize, you have to miniaturize. Second is lower cost, because the way silicon production technology works, it's you take a silicon wafer, you print many chips on it. And it's called batch production. So you don't make things one by one and build. You make multiple hundreds of things in one shot. It costs you the same to make 100 as it costs you to make one. So that batch production advantage helps you make mechanical systems at low cost, just like silicon chips, electronic chips are also made at low cost. Right? Third and fourth, fourth one is very important, real world interface. Just like I said, electronic chips really can't talk to the environment, except for a few sensors, like temperature sensors are possible in electronics, for instance. Few sensors are possible, but for the majority of sensors, right? For example, today, some of the expensive cars have pressure sensors in the tires. So the 4 tires, how much air you fill, that pressure has to be sensed and reported in the dashboard. So you have an electronic display which tells you pressure in all tires. The US, it's actually mandatory, beyond a point, because it's a safety issue. When you're driving at high speed, okay, you will never forget to fill petrol, right? But you may forget to fill air. A lot of people get lazy to fill air. So that's mandatory at this point. So there are sensors that go into each tire, and you're sensing pressure. So pressure is mechanical quantity, right? How can you have an electronic chip that senses pressure? So you have a pressure sensor chip, which is literally a cavity, and you have like a drum head. Like you have a membrane stretched on that cavity, just like a drum. And when there is pressure acting on it, this membrane will deform, deflect. And that deflection is converted to an electrical signal. Okay? Next one is choice of exotic materials. So you can literally make, you're just making micro-sized parts, right? So you can make stuff out of gold if you want. And still the cost will be low, because you're using such a small quantity. Gold was just an example. And maybe you want to make it out of gold because gold is a noble metal, doesn't corrode, etc. But you can think of so many different materials in the whole periodic table, right, which expands your ability to use a very different set of properties in your mechanical. Right? Energy efficiency, scaling of physical parameters. So I just want to dwell on that one. So that's very interesting. Anybody remembers omega equal to square root of k by m? Yeah? Mechanical, electrical, everybody uses it. Okay? What is omega? Angular velocity or angular frequency, whatever you want to call it. Km, what is it? K is the spring stiffness or the spring constant. M is mass. Right? So what does it tell you? If you have a stiff spring, low mass, then you can move it faster. Right? Qualitatively, that's what it is. Right? So imagine, just take this simple equation. Just has 3 variables in it. And let's zoom it down to the micro world. Okay? So laws of physics are same. Macro world, micro world. But the numbers you plug in into the equation changes. Right? So what is, let's just take K. What is the unit of K? Sorry, louder. Unit of K. I'm sure somebody knows, right? F equal to Kx, K is equal to F by X. What is K? Newton per meter. Okay. So when you scale K from the macro world to the micrometer sized mechanical world, Newton per meter, how will it scale? So Newton is force. So in the macro world you can apply large forces. In the micro world you can apply very small forces. So Newton becomes micronewton. Okay? Same way, meter becomes micrometer. So what happens to Newton per meter? Nothing. Nothing happens, right? So micronewton per micrometer is still Newton per meter. Micro cancels, right? Easy. So K does not scale. Interesting fact. So spring constants you can achieve in the macro world. Same spring constant you can achieve in micro. Right? But what happens to M? What happens to M? Decreases how much? Lot. You go from grams or kilograms to micrograms. Right? So you have a factor of 1 million to 1 billion reduction. Right? So what happens to square root of K by M? If K doesn't change, M drops by a factor of 1 million. So omega increases by a factor of 1000. Square root of million is thousands, right? Okay. So keep that in mind. So same equation doesn't change. You plugged in different numbers and you have an omega that is 1000 times what is achievable in the macro scale you can achieve in the micro scale. Right? So it's a real fact. You can actually make mechanical systems moving at 1000x the speed that you can even think of achieving in the large scale mechanical systems. Right? So when I was at GE in the US, we made relays. People know what relays are. Relays are electrical switches. There's a spring, there's a coil, and there's a contact. So if you turn on the coil, the two pieces of metal will come and touch, current flows. If you turn off the coil, springs back, it opens, no current flows. Right? These things, just by miniaturizing them, make it 1000x faster. And why do you need to make it 1000x faster? Simple situation. Imagine a small baby putting his or her finger in the plug point. What happens? Shock. So what is supposed to happen? The circuit breaker in your house is supposed to trip. Right? It will trip. It takes about 20 milliseconds. 10 to 20 milliseconds. Okay? So that is the inertia of the mechanical system that is inside the circuit. That much time is required for it to. But in that 10 to 20 milliseconds, the current spikes up, to believe it or not, about 10,000 amps. From 5 amps to 10,000 amps is what it spikes up to because of the short circuit situation. Right? So even though it has tripped, it has caused a lot of damage by the time it has tripped. Right? So imagine a mechanical circuit breaker tripping in 10 microseconds instead of 10 milliseconds. So the current will not have a chance to climb from 5 amps to 10,000 amps. It will probably climb from 5 amps to 20 amps to 30 amps. Right? Because current also needs time to climb. Right? Nothing can happen instantaneously. Right? Simple example of just making a mechanical system faster, what all you can do with that. Right? So that is a very powerful thing. So you can take any equation you know and simply plug in smaller numbers and see how it scales, and if it scales favorably for you, it is a great case for miniaturizing using this technology, making that mechanical system using MEMS technology for a new application that nobody has made. Right? So hopefully that inspires you a little bit. Just showing you some pictures. So these are the tire pressure sensor that goes into cars, and what you have here is the actual electron microscope picture of what's inside the chip, and you have a membrane that is stretched on cavity like a pyramid, and that deforms, you have pressure. Right? I don't want to give too much detail. A few more electron microscope pictures of mechanical systems people make on a chip. So this is all silicon. Right? So you have gears, you have rack and pinion, you have all kinds of mechanical arrangements that people make. Just to show you some examples. Okay, so there's another little seed I have to plant with you. There's something we call system thinking. Okay? So So whenever you guys have a career in R&D, if you do in the future, there's a lot of difference between how you perceive your device, what you're actually making, and the system. Okay? Just wanted to explain that with a couple of slides. So if you take the MEMS market, you have all kinds of applications. You have radio frequency devices, you have microfluidics, which are miniaturized pumps and valves, and they have what's called a lab on a chip. So in a chip you can do entire chemical experiments and so on. You have optical devices like the micro mirrors that I showed you. You have sensors like gyroscopes, accelerometers, the microphones that go into the cell phones are now MEMS devices. Pressure sensors, the inkjet heads, believe it or not, are actually MEMS devices. They actually have microphones inside. Right? So these are the market sizes. The inkjet heads are about $1 to $2 billion per year. The inertial sensors, the accelerometers, gyroscopes, and so on, are about another $1 to $2 billion. So huge markets, right? So keep that in mind. Okay. These are the markets that people are concentrating on these days. Okay? Cell phone markets, huge volumes. Right? Number of cell phones that people sell is huge. And these are the kinds of numbers that MEMS, the MEMS component of the cell phone market actually commands. Right? So the MEMS device that goes into a cell phone, like even your tilt sensor, tells you which way you're keeping horizontal or vertical, that is a MEMS device. That's an accelerometer which is sensing the direction of acceleration due to gravity. Right? So that sensor is what tells you which way you're holding the phone. Right? So MEMS devices are about $165 million per year for cell phones. Inkjet is about $185 million a year. So these are what is considered large market sizes for these kinds of sensors. Because the sensor itself is pretty cheap. Right? It's a small chip, pretty cheap. But $100 to $200 million per year market for a particular sensor is actually considered a great market. Right. So here again you have volumes on the x-axis and revenue on the y-axis. Right. Now let us think of applications like these, which are niche applications, where the revenues are high but volumes are very low. Okay, so if you take CT machines, MRI scanners, right, very, very low volumes that people sell, right? But still, they are high priced, so the revenues are high, right? So hold that thought. I'm just going to show you something here. So these are the typical volumes, so CT, wind, MRI, X-ray. Okay, just showing you an example. So take something which is the average of volumes. Right? About 7,500 units a year, $5.3 billion revenue. I'm just taking an average of all this. And let us say you are innovating for that market. And your innovation, see, your innovation is always directed towards an application. Right? So if you take an X-ray device and you are innovating some sensor that enhances the performance of that X-ray device, right? And let's say that for that you have 1/3 the market share, right? So if your innovation can improve the market share of that X-ray device by just 5%, right? So just like that humidity sensor we invented for the dryer, right? So because of that humidity sensor, if the dryer can sell, if you can sell 5% more dryers, right? So that difference is this number. Is this clear? I hope I'm not going too much into commercial numbers. But I wanted to give you a flavor for how we actually think in terms of R&D. Right? So 179, 368. If you include 5%, you get this, 10% you get this. So what I'm trying to say is these numbers are comparable to the large markets. Right? So in other words, whenever you are creating an invention, an innovation, if you can think of what value it adds to the application and quantify that, that goes a long way. So for example, when they invented the pressure sensors for car tires, the sensor is very cheap. Okay, so putting 4 pressure sensors and 4 tires may cost you $5, $10 total, that's it. Right? But you can sell the car for maybe 5 lakhs more. Right? So that is the real value of your innovation. And something that we all like to think right at the beginning. So when we innovate a new component, and whatever you're doing in your lab, I just wanted to leave with that thought, right? Whatever you're doing in your lab, you can think of not just how much that's going to cost us, but how much value that enhances to the end application, right? So if you're inventing, let's say, an air pollution sensor that will go into the next generation smartphone, okay? You'd like to know, right? I mean, when I'm walking around the street, what is the air pollution, right? So it's not about how much that sensor costs. That's one part of the equation. But if you sell that sensor to Samsung, Samsung is selling a great phone because of that. He may charge 10,000 rupees more for selling that phone, right? So that is the value of your innovation. Something to keep in mind, right? So with that, I'll just close with making one more interactive exercise, right? Maybe we can do a little more innovation. So let us think everybody's another favorite problem, right? So when we said movies, everybody was excited. Traffic problem. Everybody has experienced traffic in various places in India. So far I have seen Kanpur is great, but I don't know about, I'm sure everybody here has come from various parts of country and state and so on, and somewhere there will be a traffic problem, right? Lot of vehicles on the road, very little space on the road. How do you solve the traffic problem? Simple question. Let's innovate. So put yourself in the mind of the driver. So you are the driver driving a car. You see all cars around you. Cars in the front, cars on the side, city traffic, right? And you see a gap between 2 cars in the front, you want to go through that gap. But you can't, the gap is too small, right? That's the traffic problem, literally, right? Because the driver has to be able to negotiate and move fast. I'm trying to break down the problem for you. So it's not just the problem of having a lot of cars. So it's how, as a driver, you feel you want to quickly navigate, weave through the gaps, and reach your destination. Any ideas? Yeah.
So we will think of such a car, the material of car would be such that can shrink according to the size or something like that.
Yeah, that's a great idea. So, yeah, see, wonderful. That's exactly what it is. Yeah. So, saying don't make cars out of steel.
We would prefer
Right?
such a material that would shrink.
That would, okay, shrink may be an excessive word, but at least bend without damaging. Now you are afraid of going through the gap because you will get a big dent and you will get a scratch now, right? But if you can make cars out of a material that is flexible, okay, maybe the engine is not flexible, at least the major structure of the car is flexible. See, we are already innovating, right? Nice.
In fact,
Yeah.
now people have concepts of smart cars where they will interact with each other with the sensors that
Correct. Yeah, so maybe you could combine that with the material.
Yeah,
I find that whatever innovation we start with, somewhere we end up with material science. Because always a new material will kick off a lot of thought process. So maybe combining a self-driving, sensing smart car with a flexible car, right? Maybe even smarter car. Any other
I
ideas?
was thinking about Teflon as a material.
Teflon as a material. Why not, right? I mean, see, there is no reason cars have to be built out of
Teflon
steel.
is self-lubricant.
Yeah.
It squeeze.
Very, very true. Very true.
And it's
yeah.
very strong.
Yeah.
Very strong.
So nobody may mind if you hit the car and go. I mean, because no damage done. But Teflon is a wonderful example. Why not make a car out of Teflon? Why has nobody thought about it? Sometimes there is no reason. Sometimes you just have to think about it and get it done. Right? Yeah.
see our manual cars, normal cars,
Yeah.
only the front two wheels are eligible to give us the direction.
Right.
So if we do some changes in the mechanical function of the car and we are
Right.
able to make all the four wheels able to move in
Okay.
any direction, then we can reduce the turning radius of the car.
Very true. So in other words, let me elaborate on that a little bit. The car is not a rigid body, right? The car can, internally it is flexible. So one idea was the doors and structure is flexible. You are saying the car itself can bend.
No sir, I am saying
Not ready, so you can actually, and drive all four wheels so that you can go like a serpent, right?
No sir. So I am saying that in a normal car, only the front two wheels are
Right.
connected to the steering
Right.
wheel. If we connect all the four wheels to the steering,
Right.
we can reduce the turning radius of the car.
Ease of negotiation is what.
Ease of negotiation, yeah. Okay, good one. I was thinking one step ahead. If you can make it like a snake, you can really go through small things.
It's just a material, you have to find
Right.
material.
Correct.
What about your body?
Yeah.
You're also sitting there. So how will you move
Correct.
with it? That's also we have to see.
True. What else? And you guys see the news in China where the buses have these four legs, only upper deck is there. Right? So other traffic can go under it. Right? That's a great innovation, right? So the buses can keep going. Other traffic is not hampered by the fact that the bus is there. You can go under it freely. So only the upper deck is there. There is no lower deck. Only four legs are there. Right? That's all I know. What else? So there are more ideas, right?
Flying vehicle.
Flying vehicles, yeah. Flying cars. What's wrong with flying cars? Nothing, right? Somebody has to invent.
Increase the air traffic.
No, that's so far it's not a problem, right? I mean, you don't have to fly so high as a plane. You can fly a little bit, like few feet off the ground.
See, flying cars have been invented several times, a lot of things are there. How
Right.
to make it more viable, how to make it
Correct.
economical, and so those are the only
Right.
factors that are there.
Correct. Yeah. So there are single-seater or four-seater airplanes which are equivalent to flying cars. So car is also four-seater. But question
No,
is,
the car can literally lift up and go.
correct, right.
How much duration, is all
Right.
this has to be, feasibility has to be worked out.
Okay. Well, let me add to that. If we were to break down that problem a little bit. So when you have a flying vehicle, you require a lot of energy to raise it off the ground. Right? So moving horizontally doesn't require so much energy. It's the vertical part that is the killer. That really consumes a lot of energy. You need a
And
lot
you
of
have
fuel.
to have a bigger engine to be able
Correct.
to do it, and if you have a bigger engine, the weight goes up.
Correct.
So you have to go all the more powerful.
Right.
So it's like that.
Right.
Unless you invent some kind of metallurgy
Yeah.
with the engine
Right.
can run without increasing the weight.
Or if we remove the problem away from the problem of vertical, I'll just elaborate on that. Okay, I'm just trying to get at something where, again, repeat, horizontal movement is easy, right? That we are doing anyway in today's car also. Vertical lift is the problem, right? That is problem as it's energy consuming, right? Now physics tells you that once you have lifted once off the ground, you have the potential energy. Right? So let's say you have to lift it 20 feet, 30, whatever, 20 feet, 30 feet. You have to raise the potential energy. Right? And for that, yes, you have to supply energy to the car, has to come from some source. But after you raise it once, theoretically, you should not have to spend any more energy to keep it up there. Theoretically. Right? But the fact is, in modern flying systems, we are spending a lot of energy keeping it in that vertical position. Right? So physics-wise, the problem is actually theoretically much simpler. You only have to raise it once. Then if you find a way to let it stay there without supplying additional energy.
How do you
Right.
nullify the gravity?
Let's see. Let's see who innovates. So gravity is a force, right? It's not energy.
Right.
But if you raise it once, you spend energy. And if you find a way to keep it there, theoretically you don't have to spend energy.
It tends to convert
Right.
to kinetic energy by falling.
It tends to convert. If you prevent that,
Potential
yeah.
to kinetic.
Yeah.
So how do you stop
Four
that
up. Yeah.
conversion?
Yeah. How do you stop that conversion? Yeah. Any ideas? I hope people understand the intricacy of what we're discussing. Right? So we are raising the potential energy by supplying energy to the system. But as he said, it tends to fall back because of the force, and it tends to reconvert to kinetic energy, which is a waste for us. So we want to keep it there. How do you do that? Any hands? Yeah.
Vertical hurling can be converted into horizontal movement.
No, but still, horizontal movement is easy. Right, you want to prevent the vertical fall. Horizontal movement is a no-brainer, especially if you are going to fly. There is no friction also. Road friction also is gone. So actually horizontal movement is easier than a normal car. Right? So, see, physics tells you don't need energy for that. So, yes.
You see, it has to rest on something.
Yeah, maybe not.
You rest on something. Yes.
Right.
Sir, we cannot directly abolish the gravitational force.
Yeah.
That means we can only decrease the rate of falling. If we decrease the rate of falling, we can use less energy to make that particular equipment in the air.
Okay.
So we can decrease the rate of falling of any equipment by increasing its area.
Right.
So
Okay.
if we use the flaps or something like that, something like parachute, we can
Okay.
make that particular thing to be in the air.
Okay. Good idea. Yeah. So make it, yeah, flapping, yeah, it's a great idea because flapping is a way to stay on top with less energy consumption, right? Doing flapping, right? Which today's airplanes don't do. They don't have flapping at all, right? Anything else? Any other examples of
What he said,
levitated systems? Sorry.
what he said is already solving a problem.
Yeah.
It's like when it gets raised.
Yeah.
Okay. You have enough energy to balloon something to keep it there.
Right. So a balloon
Balloon.
is a wonderful example, right? So how to implement it is secondary.
Yes.
So a balloon is a great example. So if you have a helium-filled balloon, then you don't have to spend an ounce of energy to keep it there. It will keep flying. You only have to worry about moving it horizontally, right? What else? It could be as simple as a balloon right now. Yeah.
By applying force against the gravity, like technology that's come nowadays in the iPhone 7, when it falls, then it releases a air pressure that prevents it from falling.
So that's possible. That's like a hovercraft.
Yes, sir.
But then you need power for that. That really won't work. It's like a hovercraft. Yeah. Yeah.
Sir, we could give opposite charges to the road and the car.
Okay. Electrostatic.
Like
Yeah.
there are elevated trains now which are working. So but that.
Perfect. Yeah. So you could. Okay. So what if whenever we magnetic levitation, electrostatic levitation? Fantastic. So what if when we relay the roads, we have to do 50 years into the future now, right? We lay roads with magnetic materials or electrostatic materials, right? So when the sky is open for innovation, then we can do whatever we want right now. Yes.
Very good. Very good. Excellent.
Yeah.
The way the balloon inflates,
Yeah.
it goes in a particular direction. So we can use the air that is present in the atmosphere, so that can push the body forward and
Yeah.
use the helium to actually lift it up from the ground.
Okay.
So that the pressure within the ground is higher and above is lower.
Okay.
So that by that way the body will be in the air. And
So that's exactly how the aircraft works, right? So Bernoulli principle, higher pressure here, lower pressure there, right? That's how the aircraft works. But it needs to be moving horizontally to maintain the vertical lift. So somehow, somewhere you are supplying energy to maintain vertical lift. So we are talking about a scheme where you don't supply, you supply zero energy. Right? Okay, so then maybe I didn't understand. Can you just repeat that?
Using high density fluid. Instead, we are using air to push the body forward in the air.
Okay.
Like we fill the balloon, we throw it like something like that.
So you fill the balloon, underneath there's a balloon which keeps holding it up.
When it gets inflated, it pushes itself forward and the air comes out from that closed body.
Right.
So by this we can use that thing.
So then you will need a compressed air pump to push the air, right? That means problem.
You shape the contours such that there is pressure difference below and above. That maintains.
But to create a pressure difference, you need to move.
Yeah.
So otherwise, air pressure is same everywhere. Right. Anyway, so I think the point was to show that even something that seems intractable to start with, right? So when I say let's make flying cars, it sounds crazy. But even that, if you spend 5 minutes, you can come up with half a dozen ideas, right? And just to summarize, we were trying to say that according to physics, once you have raised it, you can actually keep it there without spending energy. Question is the engineering part. How do you do that?
How do you apply physics?
How do you apply physics?
So how well you can apply physics?
Everywhere you have to.
So how well you do it?
Right, exactly, yeah.
How
Right.
well?
Exactly, very much, yeah. So if you invent roads from magnetic material, you start laying roads. It's conceivable that the repulsion force is provided by another magnet on the car. Right, so maybe thinking aloud, maybe you have a magnet which if you flip, car flies. Flip other way, it comes down, landing, right? And then once it's a few meters above, all you have to do is to provide some force to move it. The friction will be a lot less, you just have to overcome air resistance. Anyway, so I just wanted to leave you with a thought that innovation happens everywhere. Just have to put your mind to it. Right? I'll take some questions.
So you brought actually the jet cars now.
Yeah.
Because you can actually have the jet giving reaction for forward motion and
Right.
then your magnetic levitation keep frictionless, almost zero.
Correct.
So probably you got now new cars.
Maybe, who knows? Somebody wants to invest in it, we can make it. Yeah.
So he's ready
Right.
for questions.
It's a very thin line between invention and innovation.
Right.
Yours is slightly on the invention side.
Yeah.
It's a very thin line anyway.
Correct.
How feasible, how to do it.
Correct.
How to make it
So
feasible.
finally you have to
That's
make it
where
work.
the innovation will come.
Correct. Yes. But that spark has to start.
Yeah.
Somewhere you have to start with a
Yeah,
spark.
absolutely, absolutely. Absolutely. You have to dream.
Yeah.
You have to do daydreaming, otherwise you will not be able to do something.
Correct.
Most definitely.
Thank you so much, sir, for your valuable words. Any more questions? Friends, this is the time to grab this opportunity.
Thank you, sir. Now, here the time comes that we would request our dignitaries to present mementos as a token of gratitude to our guest speakers.
I would request Dr. Kumar Shubham to kindly present the memento to Mr. Haresh K. Sippy.
request Dr. Raghuram Singh Suryavanshi to kindly present the bouquet to Dr. K. Subramanian. Put your hands together for him. Thank you, sir. Now, I would like to request Dr. Ashutosh Tiwari, Dean of R&D, to kindly come to the dais and give vote of thanks. Put your hands together for him.
Good morning, everybody. First of all, I would like to thank our visionary chairman, sir, and managing director, ma'am, for allowing us to conduct such a wonderful seminar on today's topic. Honorable Director PSIT Dr. KTV Reddy, sir, respected Director R&D and convener of this seminar, Dr. VM Wasekar, sir, organizing secretary of this seminar, Dean R&D and officiating principal of PSIT College of Higher Education, Dr. Shivani Kapoor, ma'am, our most valued invited guests, ladies and gentlemen. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, Dr. Ashutosh Tiwari, on behalf of organizing team of this event and my own behalf, extend a very hearty vote of thanks to all the speakers for gracing this occasion and sharing with us your findings and opinions today. A big thank to our chief guest, Mr. Harish K. Sippi, CMD TEMA India Limited Mumbai, for his innovative talk. And today we all saw an energetic young man at the age of 70s. Further, we are grateful to our guest of honor and keynote speaker, Dr. Kanak Sabapati Subramanian, Executive Director, Power Gear Limited, Chennai, for his talk on MEMS, that is Micro Electrical and Mechanical Systems, which can be used in dryers of the washing machines. And also we got an idea how it can be predicted that a movie can be hit or flop. We all are inspired by your great words. I am very grateful to our organizing committee members, Dr. Anurag Tiwari, Dean R&D PSIT COE, Dr. Pranay Wal, Dean R&D PSIT Pharmacy, Dr. Ramchand Singh Chauhan, Dr. Kumar Shubham, Dr. Raghuraj Singh, Dr. Ajay Pratap. We also would like to acknowledge our gratitude to our digital committee members, Dr. Amit Srivastava and Mr. Ashish Kumar. Finally, I would like to take this opportunity to place on record our hearty thanks to our research coordinators from various departments, Dr. Aparna Dikshit, Dr. Gaurav Tiwari, Mr. Anand Handa, Mr. Abhishek Dikshit, Dr. APS Bhadauria, Dr. Sudhir Yadav, Mr. Amir Khan, Mr. Lakshmikant Mishra, Mr. Rakesh Ranjan, Mr. Brish Kishore Dubey, Dr. Namita Tripathi. I also extend my thanks to Dr. Neeti Prakash, Registrar PSIT, for arranging local and air transport for our guests. No one present here can forget the efforts made by our students from Computer Science Department, Shreya and Rangoli, for the smooth conduction of the today's event. At last, I would appreciate the efforts done by Mr. Sumit for covering this event in his camera, and Mr. Avadhesh Yadav for managing print and media fraternity. I think I cannot thank everyone for their involvement and their willingness to take on the completion of the task beyond their comfort zones. We thank you all for being with us. It has been a great pleasure. Thank you very much. For the further announcement, I would like to call Director Research and Development, Dr. V.S. Wasekar, sir.
I really thank you all for your participation here, and I really thank our speakers. They have been excellent. They actually really made the awards that we had as part of their company excellent. I can't expect we can really get such rich industry learning experience. And in fact, we are proceeding for lunch hour. However, Mr. Subramaniam from PowerKit is available for further interaction, and I would like you to take maximum advantage of this. So after 1 hour, we'll meet again here for interaction. As far as our chief guest is concerned, he has to leave, so he will leave early. And we'll have photo session as well. So we can have photo session right now, and we proceed for lunch after that. I give mic to our excellent anchors, Shreya and Rangoli. They have worked hard, and they will announce the closure.
So now we have a lunch break, and I request all the dignitaries to kindly proceed towards conference room and all the participants to kindly proceed to the girl mess. Thank you for your presence, and we will meet after 1 hour.
Let us arrange here for the photo.
Wait guys, everyone is requested to kindly stay back for the photo session.
Please come to this side. Please come forward. Come on the dais.
Everyone kindly get on the stage for the photo session.
बंद है इसको निकाल के चले गए किचन बंद है
Mike. Sumit, clear? Everybody is clear? Ashutosh, आप भी आ जाइए प्लीज.
No smile or what?
Take some more.
लीड बैक करेंगे।
भाई मेरा बैग भी ले आते हैं क्या? Just move, have lunch and then come. After 1 hour. 1 घंटे बाद आना है। चलो ये सेल्फी बाद में। चलो इधर।
चलो जल्दी।
पर मैंने एक नहीं लिया।
पता कितना थी।
अरे सुमित सुमित ये लाइव स्ट्रीम में भी चल
शायद चल रही है। सर आपका सेटअप हम नहीं छू सकते क्योंकि कैमरा भी रिकॉर्डिंग ऑन है उसमें भी ऑन।
बंद कर देते हैं।
अरे आप
चीज़ें हम समझ नहीं है। आप HDMI लगाए, आपके कैमरे में भी है, आप HDMI कन्वर्ट करते हो। HDMI to HDMI क्यों नहीं कर लेते? डेटा लॉस कर लेते हो। ये आप HDMI लगाए, वहाँ HDMI लग जाए। तुम्हारी लीड निकाल लें क्यों भाई लीड निकाल लें जरूर नहीं है
इसमें कार्ड ही नहीं लगा वो ऑडिशन नहीं गया था खराब हमको बहुत काम करना पड़ेगा
निकाल दिया आराम से निकाल लेना
वो तो लाइव स्ट्रीमिंग मेरे भाई हार्डवेयर लग रहा है मुझको लगा वो HDMI से कोड आज आपकी में हमिंग आई है
बाद में ज़्यादा आई है
बाद में तो बहुत ज़्यादा आई है
बहुत ज़्यादा आई कॉलर मैक की वजह से अभी मैंने बंद कर पाई है
बाद में तो बहुत आई है
मालूम है नहीं हमें मालूम है हमें हमको खुद और बार बार कट भी रही थी आ भी रही थी
कट तो हमारे अंदर जाएगी शायद
वो चक्कर जब रेंजिंग कम हो जाती थी
बैटरी की दिक्कत हो
नहीं बैटरी की दिक्कत नहीं थी रेंजिंग की प्रॉब्लम आ रही
रेंज कौन बहुत ज़्यादा है ये और वो
अब इतना नहीं था होगा तो कहाँ से काम करेगा
स्टेज
ये सेटअप यहाँ का
दीवार उसका अलग ये तो यहाँ का सेटअप तो वो पूरा ऊपर सेटअप बाद का है ये तो भी टेम्परेरी सेटअप खाली ये दोनों स्पीकर लगाना
वही है और रीजन इसी वजह से प्रॉब्लम
वहाँ पे टंगेगा